Section 3.6, Conservation of Energy. So in the last section, we talked about the idea that energy can change forms from kinetic energy to potential energy to chemical energy and so on, but it can't go anywhere. It can't disappear. That energy is always exchanged or transferred, but it's never gone. Okay, so what this means is that just like momentum is conserved when you have things like collisions, energy is conserved all the time. So what we call the law of energy conservation just says that energy cannot be created or destroyed. It's just transformed into different forms. But the total amount in any system, or in any case, the total amount will always remain the same. A perfect example of this is what happens to the energy of an object as it falls. So as a person or an object falls, right? So let's say we start here at the top of this. He's going to jump into the bucket of water down at the bottom. So we start here at the top. At the top, he has some amount of gravitational potential energy, which is equal to 10,000 joules. M times G times H. Now, as that person jumps and starts to fall, the potential energy goes down, right? It's getting closer to the ground, so the height goes down. So the potential energy goes down. The kinetic energy goes up, because as he falls, he speeds up. It gets faster and faster and faster. So that right before he hits the bucket, all of the potential energy is gone and has been transformed into kinetic energy. And the total amount of potential energy he started with is the total amount of kinetic energy that he ends with. And along the way, you see how it changes. Now, one thing I want to point out here is at this midpoint. At the midpoint of his fall, right, the midpoint in terms of distance, at the midpoint of his fall, his potential energy and his kinetic energy are equal. Notice this is not the case for the velocity or something like that. Halfway through the fall, the velocity is not half of what it will be at the beginning or at the end. Okay? But the energy is. Right? So this is part of the reason that we use energy to understand some situations like this. Forces and accelerations can sometimes be a bit more complicated. Whereas, as you would expect, halfway through, potential and kinetic energy are exactly half of the total amount. In addition to converting gravitational potential energy to kinetic energy, there are other ways that energy can be transformed. For example, the sun uses the energy from nuclear reactions inside of the core of the sun to generate radiant energy in the light of photons and radiation that then make their way out of the sun. Water dams convert potential energy of water to electrical energy. So the water moves over the dam, spins a turbine. That turbine generates electrical energy. Similarly, plants use sunlight to run the chemical reactions. They take the energy from the sun and convert it into power and chemical reactions inside of the plants themselves. So there are lots of different ways that energy can transform, and it's everywhere. Anything that has mass has energy, anything that's moving has energy, so energy is everywhere.